Hi and welcome to Airlock videos. In this video, we demonstrate how the Airlock Microgateway is used in a Docker environment. This demo illustrates how services within a orchestration service such as Kubernetes can be effectively secured with the Airlock Microgateway. This video is aimed for companies and professionals that use DevOps or are planning to use DevOps and need to improve their security. So let's start with the introduction. What is Minikube? Minikube is a tool to run a local Kubernetes cluster. With Minikube, you can test and develop a Kubernetes deployment locally on your Linux, macOS, or Windows system. What is Minikube? Kubernetes is an open source orchestration system for Docker containers. It allows to run a local Kubernetes engine on your machine such as macOS, Linux, and Windows. Therefore, the Airlock Minikube example platform can be easily deployed locally on your Mac or Windows system. So, what is the Airlock Minikube example? The Airlock Minikube example shows how to protect backend applications with multiple Airlock microgateways and how to authenticate users upfront using Airlock IAM. It is an example how services in an orchestration system can be effectively protected with Airlock products. This Minikube example is a complete package with all the components included to demo Airlock use cases in a local Kubernetes environment. That means you can download this setup publicly on GitHub and run it on your local machine. All information on how to set up the example, prerequisites, and so on are on github.com/ergon/airlock-minikube-example. This video does not explain how to get the example running or how to install it. Instead, it covers what the example provides. It describes all the delivered components and shows some security use cases. If you need an installation guide, please head over to the mentioned GitHub page. Let's start with an overview of the Minikube example. The example can be deployed in 3 different scenarios. The first scenario is the Community Edition, which is completely free and doesn't require a license. The Community Edition excludes Airlock IAM functionality. The second and third scenario requires a valid license and is called Premium Edition, while the third one covers additionally Airlock IAM use cases. The difference between these scenarios are the usable functionalities and therefore which features can be tested. In this video, we show the full Premium Edition with Airlock IAM functionalities. Let's have a look at the architectural overview of the Minikube example. As mentioned before, we demonstrate the premium version of the example, which covers the gray part on the left and the green part on the right as well. On top of the architecture, we have a user on a computer or mobile device who tries to access a service. Then the rest of all the components, services, Airlock microgateways, Airlock IAM, and so on are deployed in Minikube. Now let's go through all the main components in this architecture. The ingress controller is the first element in Minikube. It accepts all the traffic from outside of the platform and forwards it to the pods inside the platform. Each service is accessible on a specific path. So to access Airlock IAM as an example, we need to type in the IP address provided by Minikube/auth. In the middle part of the architecture, we see that every service is protected by an Airlock microgateway. All microgateways read and write their session data into a central Redis instance. This means that all microgateways share the same session data, and therefore session handling is enabled across all microgateways. Every microgateway has its specific purpose depending on which service it is protecting. The microgateway in front of Airlock IAM is accessible publicly without authentication and filters requests, validates them against an OpenAPI specification and other security features tailored specifically for IAM use cases. The Echo Server service is an application mockup. The microgateway in front enforces authentication, meaning it is only accessible for authenticated users. Additionally, it has some restrictive deny rules enabled. Kibana is a log viewer for Elasticsearch logs and is only accessible for authenticated users. Since it collects all the logs from all the microgateways in IAM, one can analyze it centrally. Grafana is a web app to analyze metrics. Since it scrapes data from all microgateways, it is possible to analyze metrics on one single point. It is only accessible for authenticated users as well. Okay, now we have seen how the architecture of the Minikube example is built. Let's head over to the hands-on part. Let's get started. To find the IP address in order to access the application, we need to get the IP from Minikube. Of course, the Minikube with the example needs to be up and running. Then you can type in the IP in a browser. The first page shown is the login screen of Airlock IAM. The credentials of the test user is user for the username and password for the password. Now let's open up a command line. In my case, it is Windows PowerShell because I deployed the Minikube example on a Windows machine. To find the IP address, I can use the command minikube IP. On my local machine, the external IP address of Minikube seems to be 172.30.428. Okay, let's use this IP in the browser. The first page that you will see is the login screen of Airlock IAM. Now I use the username, user, and password. The portal page shows you the following apps. For the admin tools, we have Kibana and Grafana, and as the application mockup, we have an Echo service. Let's open all the apps and go through them individually. Elastic shows all the logs from all microgateways and Airlock IAM. If we go to the menu to dashboards, we can choose one to analyze the current situation. Let's choose WAF attacks. The WAF attacks dashboard shows attacks over all microgateways in our Minikube example. Please note that all shown data are generated artificially and are only used for demo purposes. Now let's switch to the Grafana app. The Grafana dashboard displays metric data from the pods running in Minikube. The default dashboard shows metrics of workload. Here on the top part for each service and pod. Then we see request load for each service and pod. And if we scroll down a bit, we see session statistics for each service and pod. And on the bottom, some timing statistics in percentiles to quickly determine where processing time for a request is being lost in a service or pod. Now let's go to the last part of the Minikube example, which is our Echo service. The Echo service is an application mockup which echoes or responds to specific requests described here at the bottom of this page. We can use the Echo service to test if certain Airlock Microgateway settings are being applied. As an example, if the deny rules work and if request or response actions are being applied. So basically, we can change the microgateway config and redeploy to see if the changes work. Let's start with a simulated attack. In this case, we try to do a HTML injection attack. We add this URL parameter in the browser search bar, $A R2D2HR. Okay, this request has been blocked. And what we see here is the error page from Airlock Microgateway in front of the echo service. We can now copy this request ID in order to analyze the block. Let's switch to Kibana and paste the request ID into the search bar and select the Airlock WAF default index. So let's open up the first log entry, and we see here that the request triggered a deny rule, in this case the HTML injection in parameter value rule. So that was a very short overview over the Airlock Minikube example, and I hope you enjoyed this quick video. If you need more information, please head over to our documentation page, docs.airlock.com. There you can find a link to our GitHub page where you can download the Airlock Minikube example. And for all other information, please head over to our main website, which is airlock.com. Thank you very much. Bye-bye.